Good day, viewer. Here I'm doing my second physics project, wherein we had to create a hierarchical AABB system for detecting large amounts of triangles in a scene. I just have collisions set up for those triangles and spheres. Apologies for any sound that might leak through. There is a party upstairs. I'm not part of it, no worries. I don't want to be part of it. Anyways, jumping right into it, I'll quickly give a rundown of what I did. I chose to go for an Oct-Tree here. So it starts off with just bounding the mesh in its entirety in one box, and then splits that into 8 different smaller AABBs, each one representing a quarter of that total bounding box. And all it does is to each of those smaller boxes, it passes a bunch of triangles. It runs a quick little check to see which of those triangles are in the bounds of that box, and then checks if it's that many triangles that comes out of that is less or equal to a value that we give initially. So in this setup here, I have this at 150. So each leaf AABB, if you can call it that, will only have a maximum of 150 triangles in it. Let's quickly go over here. Here's where it creates all the children and sets their lengths as smaller parameters of the current box that this is in. And then it calls the make tree on that. So this will go in for this smaller AABB with all these triangles that this parent one has. And it'll call all the triangles that aren't in the bounds that this box makes up. And then it checks if it's less than or equal to the amount of triangles that it was given here. So it just passes on that value right there. And it just goes down, 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 down. And then once it finally has enough, or is small enough, it'll just set that AABB's triangle vector to that many triangles, and it'll return becoming a leaf. Traverse is pretty simple. It just starts with a big box. Is the sphere in this box at all? If it is, which sectors is it in that box? And then I can jump into it really quickly. So yeah, it checks quickly if it's actually in the box itself, and if it is, we start the recursive step where we give it the radius of the sphere and the sphere's position. That's all it needs. So we check, these are all the children we'll be checking, and it goes through these steps to prune which ones we will not check. Create all these vectors for these children to return. And it just goes through and it calls the recursion steps. So it'll keep going, 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 going until it gets a leaf. And when leaves return, it'll get all these back, and then it has a little vector triangle union here. Pretty simple, because with each triangle that I stored in the model itself, I have an ID related to that, so everything is in order. So these vectors or returns can be, it can be ordered from smallest, or yeah, it's ordered in ascending order, so I can easily start at the smallest vector and then add whichever one is smaller, and then I'm a bit scatterbrained right now, so you can just look at that and figure it out. Smile. Anyways, let's jump right into it. For this project, I have generated in MeshLab a 2 million and something face terrain here. And I put another one up there just to showcase how efficient this is. This model has detection, one sphere on the nose, one sphere on either of the wings, and one sphere on the top tail there. Quaternions make me want to pull my hair out, so this thing is very static, but it does move in 3 dimensions using WASD. Shift and space to go up and down, and then like wherever, if you want to hold down W and look in a direction, it'll go that way. But as you can see, I can bump into something here, and what it does, it negates the current velocity of the ship here based on what the average of all the triangle normals that it hits is. So if it's moving in this direction, a normal will be facing that way and block out all of the, say, Z direction. This is the Z axis here. But if you hit it at a weird angle where a normal wouldn't cancel a vector, you can get a little bit of a bounce like that. So as you can see, yeah, it was just moving in the Z direction there. And of course, it works for the roof here, and you can see it'll hit the top fin, boink, and stick in there. So it won't let me move any more in that direction, but I can easily just kind of leave, go out, thunk. So no real collision response, it's just detection right now, and it works pretty well. As a plus, I ran this in debug mode, and after waiting about 5 minutes for it to start up, it runs about as good as this. So it's very efficient. Again, I have this set to 150 triangles per leaf because I feel like it would take too long in release, or in debug definitely. I guess release is always pretty dang fast. But yeah, I'm pretty happy with how this turned out. I'm looking forward to looking into responses in the near future. I guess that's about everything, folks. Thanks for tuning in. Have a good one.